So again, we're going to take what we got for x, plug it in to the other equation. So that's what I'm going to do. We used the first equation, right? You really want to use both, so that's what we're going to do here. So I'm plugging it in for x into the second equation. And we get 2 times 18 minus 4y, right? Minus 3y is 14. And we get, and now what do we do? Well, let's simplify this a bit. Yeah. So we have 2 times 18. 2 times 18 minus 4y, we're going to distribute. And so we get 2 times 18 minus 2 times 4y minus 3y is 14. That's what we get here. And so what happens here? We have 36, right? That's 2 times 18 minus 8y minus 3y is 14. And so 36 minus 11y is 14. Right? Essentially, we now have one equation with one unknown, y. Y is the unknown. So now we have to solve for y. So let's do that. 36 minus 11y is 14. Okay, so what do we do now? We want to get y all alone. Let's subtract 36 from both sides. Right? We get negative 11y is negative 22. But we don't want negative 11y. We want y. So we divide. Divide by negative 11. We get y equals 2. That's what we get. So y equals 2. That's good. But now we know y equals 2. Are we done? Well, just like the first problem, just like with the elimination method, no, we have to get x. But that's actually easy because we know what x is in terms of y, right? That's what we have here. We know x is 18 minus 4y. So we substitute. We get 18 minus 4y is 18 minus 4 times 2, which is 18 minus 8, which is 10. So the only solution is 10, 2, the ordered pair. And this is something I would recommend you do. I would recommend you check your work using Desmos. I mean, you could plug it in also. That is, you could replace x by 10 and y by 2 and see that both equations hold. But you can also use Desmos. Namely, let me just show you. I could graph this. Let me just get rid of this. Okay. Let me share Desmos. Okay, hold on, here it comes. Good. Actually, you know what? Let me do this. If you go to Desmos, right? You know, this is the site you come on to, although you may not be logged in as Adam, which is how I'm logged in, because Adam's my name. And we go to the graphing calculator. So we type in the equations. Okay, that's what we do. We get 1 over 2 times x plus 2y equals 9. And the other one, if I remember correctly, was this. 2x minus 3y is 14. And you can see it's off a little bit, so you may have to click and drag. And you could see, oh, they both intersect at 1 point, 10, 2. And And that's good. That's what we want. So decimals is nice. It's a good way to check your work. Now, are there any questions on this? Okay, well, let's keep going then. Going with the notes, I mean. Yeah. All right. So this is something that I have gone over before, the LCM, the least common multiple. Namely, remember that what a multiple is, I have the definition there. If you have, you know, n is any integer, right? The multiples of it are these numbers. I mean, really, maybe I could skip 0 here because we're going to look at the least common multiple. But basically, you're just taking n and multiplying it by non-negative integers. You know, like 0 times n, 1 times n, 2 times n, and so on. For the multiples of 3, okay, right? For instance, we have 0, 3, 6, 9, 12, and so on. So we have this notion of the least common multiple. Namely, for any two non-zero integers, m and n, the least common multiple of them is the smallest positive integer that's a multiple of m and n. So 0 can't be the least common multiple. And here's just a quick example. I mean, really, there are advanced methods using number theory for finding this. For now, all we can do is list them until we come across the first positive multiple of both m and n. 6 and 8. So you can see that the least common multiple, it's not 0 because it has to be positive. It looks like we get 24. Okay. So here's an example where we're going to use the LCM, the least common multiple. Let's solve this equation. We're going to solve this equation. Namely, what we want to do is get the least common multiple of the denominators, and we're going to multiply both sides by it. I mean, really, you can use any number you want that's a multiple of the denominators. The least common multiple is the easiest to use, is the smallest one. You just want to clear denominators somehow. Yeah, I've seen people, what they would do is they would get a common denominator. They would take 5 and convert it to 20. 2, they would convert to 20, and 10 also. That's fine. You know, as long as you show your work, I'm okay with what you do. But anyway, for 2, 5, 10, and 20, if we were to list the multiples, the non-zero ones, I should say, as you can see, we have 2, 4, 6, 8, and so on. 5, we have 5, 10, 15, 20. 10, we have 10 and 20. 20, we just have 20. You can see that the LCM is, we have 20, right? You can see that the first positive integer that's in all these lists is 20. So 20 is the LCM. So we get that. $20 is the LCM. All right, so what do? We're multiplying both sides by 20. That's what we're going to do. Multiply both sides by 20, right? Because what happens? we distribute. And what's going to happen is these denominators are going to cancel, as you'll see on the next line. Right? First, we have 20 times 3x. Here we have 20 times 1 over 2 times x. Of course, the 2 cancels with the 20, the 2 cancels, and the 20 becomes 10. Here we have 20 times 2 over 5 times x, well, minus 20. 5 goes away. This 20 here becomes a 4. Here, the 10 cancels. The 20 becomes a 2. And of course, over here, the 20s cancel, like so. So what are we left with? 20 times 3x, 60x. 10 times 1x is 10x. 4 times 2x is 8x. Well, 4 times 2x, I mean, we're not quite there yet. Here we get 2x. Here we have 7. And then we write this as 60x, 10x. Negative 8 minus 8x is 2x plus 7. And again, now the hard part is done. Those denominators are gone. So really, you don't have fractions anymore. Now we just simplify and solve for x. You know, the left-hand side here, you get 62 times x. Here, we get 2x plus 7. So what we get then is 62x equals 2x plus 7. But again, we want to solve for x. So what do? Well, let's get x all alone. We're going to subtract 2x from both sides. We get 60x equals 7. Okay, that's what we do. 60x equals 7. And so then we want x. So what do we do next? We divide by 60. Doing so, these 60s go bye-bye. We get x equals 7 over 60. And that's our answer. Again, we really could have used any number that's a multiple of all these denominators. You could have multiplied all these denominators together. You could. I mean, the number you would multiply by would be big, but that would work also. Any questions on this?